Okay, so I'm going to create a class, just a simple Java class, not JavaFX yet, just a simple class. So Java project, and we'll just call this what, chapter 32 threads. Finish. Okay, so now I'm going to go ahead and create a new, this is fine, package. Just call this that chapter 34 threads, and then I'm going to create a class. I guess just call it main program is fine. I need a void main. I don't need a constructor. So just a typical, regular Java program. This is a thread. It runs the main thread, right? And then, so for example, if I go back to my code up here, and if I just put that code in there, we'll see the different states right here. Okay, so if I put that in here, and just to see what the states are. Okay, so the thread class is already part of the Java program, so it knows that's a thread, and it's going to print the states for each of these threads for the thread here. So you can print out probably about 6 different states here. So let's see here, that has the new, right? The new, the runnable, the block state, the waiting, and then timed waiting, and then the terminated, which is the finished state. So it runs these threads, and it prints out all these different states, and then it terminates that thread. Okay, so this one here kind of show you those different phases in the thread. But to create a thread is basically you just do this. Thread, and then you give it a name. Okay, we call it T1, and new thread. Okay, once you create it, you have to start it. If you don't start it, doesn't do anything. So T1.start, right? And when you start it, then it will start the thread. This thread doesn't do anything. It's just, we just create a column thread, and then we just start it. It doesn't do anything, so it just basically runs it and then stops it. Okay. So I have the main thread plus this thread called T1. And if you run this really quick, as you can see, there's nothing, right? There's nothing there. So this is not really useful, not very efficient. So typically when you do a thread, you want to create a custom thread that will do something for you. Okay. So you can have a program, another thread out here to do a certain task. So that is usually become in the form of a class. And I will do something like public class, we'll call it thread1. And this class will extend the thread class. Okay. And what does it say? Okay, just threads class, and in here I have to override that run. So if you, because this is the parent thread, if you do a right click, and I think if you go to sources, and if you go override implement methods, it will list all the objects or other methods inside that thread class. You can see there's like about a dozen of them. If you want to override this method called run here. Okay, you can do that and click OK, or you can just override it. You can type it yourself, right? And I'm gonna delete all these stuff here inside this thread. I want to do just basically just print something, for int I 0 through I less than, let's just say 1,000, equal to 1,000, and then I plus plus. All it does is just prints it out to the screen. So it says sys out, okay, print out the I, right? So here, instead of just thread, I will use this thread class I created called thread1 to run its job. So I've changed that to thread1 and thread1, and now it will start the thread. Okay, and let me do this. So when you run this, you see that it prints it really fast. I mean, it's just so fast you didn't see it. Just prints from 0 to 1,000, and just like the blink of an eye. Okay, that's too fast. So you could also pause as you can see a little bit slower. So right after I printed, I can say sleep for like maybe a tenth of a hundredth of a tenth of a second, right? This is like 0.001 second. And you want to put a try catch around that. It's just required. Okay. So it will pause it for about 0.010th of a second, and then it will print out the numbers, continue printing number after that. So let's see if that does something. So you can see it's kind of printing a little bit, right? Slows it down. You can see it doing it until it reaches the 1,000 number, then it will stop. So without pausing, you can't see it. Just goes so fast. Okay, so that's one thread. Now I'm going to duplicate this, and then right down here, I call this T2, and T2 will do the same thing. It would use a T1 at the same thread, but it will also print its own 1,000 numbers. Okay, and let's see what it looks like. Maybe I should put here like. Well, I can't differentiate it. But let's see if I run this. You see that both are running at the same time, right? So T1 does not, T2 does not wait until T1 is done. It's running at the same time concurrently. And although you see that one is like almost like ahead of the other one, but without a thread, this would not be the case. What would look like without a thread? It will print 1 to 1,000, and after that it will start again 1 to 1,000, right? But with the thread, they run at the same time concurrently, same time. Okay, so it's just going to prove to you that they do run at the same time at their own time. And if you have a third one, then you have a third thread running at the same time as well. Okay, this one I'm using a thread that runs on the extensive thread method here. You could have another thread called thread2 and have thread2 run its own data at the same time, its own task, right? Instead of doing this, I could have like, this as thread2. Okay, we call this thread2, and instead of running 0 to 100, for like we can do like 1,000. 1,001 to maybe 2,000 for this one. Okay, and we'll pause this, not 10s, but maybe just like 2, because 10 is a little bit slow, as you can see. And then now thread 2 will be calling on the thread 2's task, and then thread 1 will do thread 1's task. Okay, and kind of the same thing. It's numbers, but you could have print like characters instead. It doesn't matter. And again, when you run this, you see that they run at the same time. Okay, one runs, and then the other one also runs, and you have those numbers going between. So you can see sometimes here, right? Thread 1 runs twice, thread 2 runs twice, thread 1 runs once, and thread 2 runs once, and then they overlap, and so on. That's you can't really manage how one should run on the other. Okay, so sometimes because it's a little bit slow on thread 1, thread 2 overtakes it, and so on. And if you run again, you should not get the same result. It should be different every time because of the randomness in the thread. Okay. So you could have like thread 1 here could be processing, some data in the background while thread 2 is doing something else. Maybe setting up another piece of data just to run and so on. Okay, so this one here uses the thread methods class to create a thread. Another way to create thread is to use the runnable. So here, I could easily just change this to something like this. I'll use the yeah, I'll keep this as it. I'll just copy it. I'll put it down here. We'll call this thread 3. And instead of extend that thread, we're going to use the implements the runnable interface. So that already also, you need to implement the run. So for example, if you take this out, it's going to yell at you. Say you need to implement the run method, which is this one here. Okay, so we're going to copy this and kind of do the same thing, except maybe we'll do like we'll do different numbers. We'll start with 2, and then I guess 3 here is fine. Okay, so this one here implements the runnable. Now, remember the interface cannot be instantiated, right? It can, but not directly. So inside here, actually, there's a blank constructor that can instantiate this thread 3, right? You cannot have, like, for example, I cannot go in here and say runnable or is new runnable, because it's an interface. It doesn't allow you to create objects out of that. You cannot do that, right? So, but once I implement that through a subclass, then I can create this object indirectly from this thread 3. So now I can now say here, I can create a thread 3 called T3, new thread 3. Okay, notice that this thread 3 here is not it's not really a thread because it doesn't implement the thread class. So to make this, so when you do this way, this is becoming more of a task. So you treat this as a task to do something. Now to make this run, then I need to create a thread using the thread class. I will call this maybe T. I guess we can call this instead of 3, maybe we call it task or something. It makes more sense that way. So the T3 will be called from the thread class, and it's going to be assigned to the new thread, and then it takes a parameter called the runnable to target. And this is a runnable because this implements the runnable method, interface, right? So now I can put the task in here. So this thread 3 will perform the task in there for us. And then now again, I need to start the thread by issuing the start method. Okay, so that's another way how you can create a thread. And then if you run it now, you have 3 things running at the same time. Okay, so here's the first thread. The second thread ends actually slower than the third thread. You can see it finished first there before the second thread. The first thread. So another way you can do thread is you can have an anonymous thread. You could do, like, if it's just to run a task and you don't need to do anything anymore with that thread, then you can use anonymous one, because here I could do a stop, and then after that I can do some coding here. Again, I can issue T3 to start again, right? Okay, it's a variable name. But if you don't care about the name there, then you just have anonymous that run a certain task. Then you can do something like a new thread is equal to no, you can have, yeah, new thread is equal to new thread, I think new thread, and in here you could have the new runnable. So I put everything inside the thread here. I mean, if you look at this, it's like kind of same thing of doing things, right? You could, so this thread here is like calling this thread, and inside I put the runnable class interface in here. Instead of having a name, I could put here, for example, I could do task, right? And then just do start, okay? Right, that runs too. So you have that thread, is no name, it runs it once. And if you want to also have the anonymous class, so here, this task is being called here because it has an outside class called thread3. If you don't want to have a class at all like this, anonymous class, then you can do it thread, and then in here you put the new runnable, right? If you remember from the lambda expression stuff. Inside here, then basically you have to implement this whole thing. Okay, so I could copy the whole thing there and put it in here. Okay, and then now I just do a start. So this one here is the same as this, except this whole thing replaces everything from here to like here. Okay, and then dot start, it's dot start. So you run the thread. Just show you like there's so many ways you can do, and not just thread, but you can do this as well with other classes as well. So that's another way. Another way you can do is you can use a lambda expression. So instead of doing all these here, right, I could just copy this, okay, and omit the runnable and omit the run also. And here I just put something like this, the paren, arrow, and then that. Put that loop in there, and then again start. Right? So you can see so many ways to do it. Yep.
I have a quick question about, because I'm getting an error where I put thread 2, T2 equals thread 2, thread 3. It just says it can't be resolved to a data type.
Where is it up here?
Yeah.
Thread 2 here?
So if I, you know how like you got like the fourth one down is just thread T3 equals new thread, but when you when I did it like you did it with the numbers afterwards, I'm getting an error.
You put a number here, you mean?
Yeah. You see what I'm saying? Like all the other ones are like thread 1, thread 2, thread 3.
Mm-hmm. Right. So this one here is just the it's like the main thread. Okay. So you can't you can't put thread 2 or 3 here, right? Is that your question? It has to be the same thread. Did you put a number there after the thread?
Yeah, the same.
Yeah.